Imagine a material that could curb an earthquake or an invisibility cloak that lets you sneak out of school. Sounds like science fiction? Well, what if I told you it's not? Say hello to the world of metamaterials. Metamaterials are custom designed microstructures that are not naturally found, which can be used to manipulate waves. These microstructures are crafted with precise shapes, geometry, size, orientation, and arranged to form incredibly intricate patterns which are less than half the wavelengths of the waves. These patterns hold the power to control waves. It's not just the base materials that matter, it's how you structure them. Now, metamaterials gives us the power to not just mess with light waves, but also acoustic and electromagnetic waves. It's like having a Swiss Army knife for physics. Now, about making a real-life invisibility cloak, for that we need to achieve something called negative refraction. According to Snell's law, when a ray of light enters a medium, the angle of incidence and angle of refraction are related by the refractive indices of the two media. Now, if the refractive index of the medium is negative, then this means the path of the ray is reflected from the normal to the surface. Now, watch out, Harry Potter. With the negative refractive index metamaterial, we could have an invisibility cloak of our own. It bends light around an object instead of reflecting or absorbing it without producing shadows, rendering it invisible. This is similar to how water bends around a stone when placed in a river stream. So someone downstream of the stone will see smoothly flowing of water and will not know the stone is there. In the stream, the stone is effectively invisible. No, a fully functioning invisibility cloak doesn't exist in the visible spectrum today. However, researchers in 2015 made a breakthrough by making an invisibility cloak which works in the infrared spectrum made from germanium. Metamaterials aren't just good for invisibility cloaks. It can boost terahertz spectroscopy to detect drug changes without damaging the tablets, and improve solar panels by overcoming efficiency limits due to sunlight angles with turnable metamaterials. And get this, they can even help reduce earthquake damage by cancelling out seismic waves by destructive interference. Thank you for joining me on this wild ride through the world of metamaterials. It is safe to say that the world of metamaterials have a bright future, or rather should I say an invisible one.